A special and a warm welcome to you all, our dear viewers. This is another Junior Taki production, and I'm your host, Mr. T, and I'm delighted to be presenting to you a lesson focused on grade 10 Euclidean geometry. This will be a practice video, so I urge you to get a pen and a paper, and please try to attempt to answer these questions before we review the solution. So let's look at the first question. In our first question, we're told to solve for x giving reasons. If you look at that diagram carefully, it is a triangle ABC. But as a rule of thumb in geometry, you always want to work from the known piece of information to the unknown, which is what you're required to calculate. So let's look at that diagram carefully. Our known could either be given in words or it could come on the diagram. But from that diagram, we can clearly see that the side AB is equal to the side BC. And that is based on the lines drawn, those markings. It shows that those two lines are equal, or those two sides are equal. And because those two sides are equal, we can make a conclusion that triangle ABC is an isosceles triangle. It's an isosceles triangle. And from theory, isosceles triangles have two sides which are equal and also two angles which are equal. So my next question is, which two angles are equal? It would be the angle A. It has to be equal to the angle C. So that means the value of the angle C is actually x. So my first statement there, to formalize my solution, I'm going to say the angle C is equal to angle A, which is equal to angle x. And the reason for that, when dealing with isosceles triangles, we say angles opposite equal sides. So angles opposite equal sides when proving that angles are equal. Now that we know all the three angles that make up that triangle, we can come up with another statement through saying the angle x plus the angle x plus the angle x plus 24. That should give us 180 degrees. And what is the reason for that? We're dealing with interior angles of a triangle. Or some people would want to say sum of angles in a triangle. We know that they add to 180. Now that we've got that linear equation, we can say 3x is equals to 180 minus 24. 3x will be equal to 156 degrees. Dividing by 3, we get our x value, which is the required answer, as 52 degrees. We move on to the next question. In our next question, we've got two triangles, triangle PQR and triangle STR. Part A. Prove that triangle PQR is similar to triangle TSR. In order for us to prove similarity of any two triangles, we have to ensure that we prove that corresponding angles are equal or corresponding sides come in the same proportion. So looking at that diagram again, we want to work from the known to the unknown. We know without a doubt that the side PQ is parallel to the side ST. That's a given. But because those lines are parallel, we know that parallel lines are associated with alternate angles, corresponding angles, and co-interior angles. Remember the word fun from grade 8. So my point of departure here would be to state that the angle R1 is equal to the angle R2. So I'll say angle R1 is equal to R2. The reason for that is that we're dealing with vertically opposite angles, and we know that vertically opposite angles are equal. If I move on, I can make another statement and say the angle Q, that angle Q has to be equal to the angle S. So angle Q is equal to angle S. And that is true because we are dealing with Z angles, which are alternate in nature. So you can say Q is equal to S, alternate angles, but do not forget to state the parallel lines. The parallel lines in question are PQ is parallel to ST. You've got to mention that. Then you can also state that the angle P, that angle P, is equal to the angle T. Again, we are forming Z angles here. We are forming Z angles. So you can state that P is equal to that angle Z. Sorry, P is equal to angle T. So P is equal to T for the same reason, alternate angles, and you've got to state the parallel lines. PQ is parallel to ST. Then I can make a conclusion in the end to say triangle PQR is similar to triangle TSR. The reason for that is angle, angle, angle. We've proved it through using 3 angles, and therefore it's angle, angle, angle. We'll move on to part B of that question. We're required to determine the values of x and y. Now, to get the values of x and y, we're going to write the ratios of our sides. PQ over TS is equals to QR over SR, and that is equals to PR over TR. And that statement is supported by the proven fact from A that we're dealing with similar triangles. Now I can make a substitution there of all my known values of my sides. So PQ, for instance, is 12, so I can say 12 over x is equals to y over 40, and that should be equal to 8 over 20. I'm going to start by working x. And to work out x, I'm going to use the ratio 12 over x and 8 over 20. And that leads to the following equation, which comes in the form of a fraction, which is 12 over x is equals to 8 over 20. If I cross multiply there, I'm going to get 8x is equals to 240. So 8x is equals to 240. Dividing by 8, we're going to get our x value to be equal to 30. So the length of x, st, is 30. We do the same thing to get the value of y. But to get the value of y, I'm going to use the ratio of y over 40 and 8 over 20. So I write it as y over 40 is equals to 8 over 20. I then cross multiply again, and I'm going to get 20y is equals to 320. Solving for y, I get my y value to be equal to 16. I hope you enjoyed that session. Until next time, signing out is Mr. T. Bye-bye.